So our goal today is to be able to check whether our answers are correct when we're doing one of these systems problem. So before that, I want to go back and remind you how we checked back in first semester. Notice this equation right here is not a system. It's just one equation. There's only one variable. It's all x's, right? So let's say you solved this equation. Do you guys, and your answer came out to be -5. Do you guys remember how we would check if -5 was the right answer to this system? Do you guys remember what we did last semester? What did we do? We plugged it back into the original equation for this x, or for all of the x's? For all of the x's, right? So can I get you guys to rewrite this equation exactly as it is, but leave some blank parentheses where the x's are? And don't put that number in just yet. I like to leave my blank parentheses first and then double check that I've copied everything correctly. So that's the exact same equation. I just left out the x's. And then I go back after I've double checked that it's exactly the same as the original. Then I will go back and fill in the blank parentheses. This is kind of a divide and conquer strategy that I use because sometimes when I try and do too much at the same time, I make mistakes. So we thought that the solution was -5, so I put -5 here and here in the equation. Now what are we going to do? We'll kind of simplify both sides, right? And what are we looking to happen on both sides? Ultimately, what do we want to happen on both sides? We want them to be the same number on both sides. We want them to be equal. We want a true statement, right? So let's do this. 4 times -5 is being -20. And I'm going to leave that alone for right now. What can I do over here? I should do the multiplication first, right? Before the addition. So I'll leave the -6 alone. 2 times -5, that's a positive 2 times a -5, that's -20. Oop, -10 rather. -10. And then let's combine -20 and -16 is going to be even more negative. That's -36. And this is -16. And those are not equal to each other. So what does that tell us about -5? -5 is not a solution. -5 is not a solution. So something went wrong when we tried to solve it. So you would want to go back and check and see if you could find a mistake. And what kind of mistakes would you be looking for? What are the types of mistakes that you make a lot when you're doing math? Everybody does it, by the way, guys, including myself. The signs, pluses and minuses, right? That's almost always 75% of the time. That's where the mistake is. Anybody ever do the thing where you just copy a number incorrectly from one step to the next? I do that all the time. The worst is when you copy the problem down wrong, like you copy it out of the book and you copy the problem down wrong, and then you do it correctly, but you're not doing the right problem. Yeah. Anyways, that's not our solution. Can I get you guys to go back and do the exact same thing, but check +5 this time? See if that works. Stick a +5 in place of all your x's. And then simplify. Wahoo! Did you get the same number on both sides? You get 4 equals 4. So what's that mean? It's a solution. What's a solution? 4? 4 is a solution. 5 is the solution. 5 is the thing we put in for x. We put 5 in for x, and it made a true statement. So 5 is the solution. So let's write that down. 5 is a solution. So this gets a little tiny bit more complicated when we start dealing with systems, because with systems, we're going to have both x's and y's in our equation. Same idea, though. We're just going to substitute them in and see if they work. What you got to be careful of here, though, is making sure you get them in the right place. So I like to label. So this says -3, 8. Which one of those is the x, the -3 or the 8? The 8 is the x, or the -3 is the x? The -3 is the x. I'm going to put a little x under there, and I'll put a little y under my 8. And then I'm just going to do the same thing we just did. I'm going to rewrite my equation. But this time I'm going to put -3 in for x and 8 in for y. And it's really, really easy to flip these around and get them in the wrong place. So once you do that, double check that you put them in the right place. -3 needs to go in place of the x. So it needs to go in this spot here. And 8 needs to go in place of the y, so it needs to go there. And then we'll go ahead and check it. So that's just 8. Negative times a negative is going to give me a positive. So that's 18 minus 10. So 8 equals 8. Hey! That's a true statement. 8 equals 8, which means that -3, 8 is a solution. So what do you think is going to happen if I try to put a different solution into the same equation? Since we already found one that is a solution, is it possible for us to have another thing that also is a solution? Okay, give it a try for me. Do the same thing and let's see. Now, there's no guarantees. This might not be, but you think that it's possible to have more than one solution. Can I get you guys to pause wherever you are right now and look up at my screen? Can you please identify my mistake here? What did I do? I flipped my x and y. I wrote them in the same order that they were here, but they're in a different order in the equation, aren't they? So I'm going to fix that in a second. But again, it's really important to double check. And I like to label my x and y on here to keep myself from making that mistake. Thank you for correcting me there. Let's get that fixed. So the y was -16 and the x was 1. So I've done my check and I found that this is also a solution. So we found 2 different ordered pairs, 2 different points that were solutions. How many different solutions do you think there are? Do you think there's more? You think there's like 5? You think there's 100? Do you think there's 1,000,000? Even more? There's an infinite number. Thank you for that word. There's an infinite number of solutions. I'm sorry, an infinite number. Thank you. So when you're dealing with an equation that has x's and y's, there's an infinite number of different solutions for that particular equation. Now, this was not a system, right? This equation that we were just dealing with, this is a single equation. A system of equations has two equations. And actually, in Algebra 2, in a couple of years, you guys are going to be dealing with systems of equations that have 3 equations or 4 equations. And then those of you who go on to linear algebra in college, you might deal with systems of equations that have 10 or 20 equations in them, which is pretty awesome. And at that point, usually you use a computer to solve them. But in Algebra 1, we're going to stick with systems with just 2 equations. So if we're looking for a solution to a system of equations, meaning more than one, it has to make every equation true. Okay, and this is where sometimes my students get a little bit annoyed with these, because what this means, it's not enough for us to test our solution in just one of the equations. We actually have to test it in both, because you will run into a situation sometimes where your solution works in one of your equations, but it doesn't work in the other one. So let's go ahead and do this system of equations here. I'm actually going to go ahead and write out both of these equations side by side, but I'll leave out my x's and y's. So the first one is y equals 4x minus 15. And my second one is y equals 2x minus 7. And I'm going to have to plug these x and y coordinates into both of those equations and check both of them. So I've labeled my x and y coordinates so I don't make that same mistake again. The y is -3, so that would go there and here. And the x was 3, so that would go here and here. And then we just have to do our work and simplify. And what I'm hoping for is that both of these end up giving me true statements. So that's 4 times 3 is 12, minus 15. -3 equals 12 minus 15. -3 equals 12 minus 15. Hey, that one works. Boo. Does the other one work? -3 equals 2 times 3 is 6. 6 minus 7. Ah! All right, I got a really big important question for you here. Some people are still writing. Looks like some of you are working ahead. Can I get your attention really quickly up here? What have we learned about this solution? 3, -3. Is it a solution to the system? The answer is no. Let's write that down. Is not a solution to the system. Now, let me let you finish writing that down, and I have another couple important questions for you. Can you put your phone in your backpack, please? Thank you very much. All right, look up here for a second. Is 3 comma -3 a solution to the first equation? Yes or no? It is a solution to the first equation because it made the first equation true. Is it a solution to the second equation? No, because it did not make a true statement. And since it's not, we didn't get 2 yeses, then it's not a solution to the system. So it's got to be a solution to every equation, which means you got to check them both. Could I get you guys to go through this process for 4, -1 in the next system? What'd you guys find? Yes or no? Does it work in both of them? It did work in, so we can say it is a solution to the system. And it's a solution to both equations. Now, where might this be really important? When would you find yourself actually using this? In a math class, let's say. Check your homework. Yeah, if you're doing your homework and you want to check your answer and see if your answer is right, this would be a great way to do it. Now, we've been talking our way through this and it's taken us, I would say, even if you're pretty sure, because I can point to lots of times I was pretty sure I had the right answer, but I made a mistake someplace, right? You usually don't, that's a mistake. If you caught yourself making the mistake, then it wouldn't be a mistake anymore, right? So so I'd say in a test or a quiz, this is vitally important, right? You definitely, if you have time at the end of a test or a quiz, you want to go back and check your solutions. And on our next quiz, the one we're going to do on Friday, I'm actually going to give you bonus points for doing this. So what it's going to say on the quiz is there's going to be a problem, and at the bottom, so there'll be a problem up here. Here's my problem, a couple equations, and you're going to work it out, and you're going to come up with your answer. Okay, and I'll have a spot for you to put your answer. And underneath this, I'm going to say check. And if you show that work that we just did today, that's going to earn you some bonus points just for checking. And then underneath that, I'm going to have a sentence that says, is your answer a correct solution? Yes or no. Now, if you checked and your answer is not right, even if you can't figure out what your mistake was, if you circle no here and your check shows that it's not the right answer, you're still going to get bonus points for it. And those bonus points are going to be almost enough for not getting the answer right in the first place. Do you see what I'm saying? So you want to do this, even if you make a mistake here, you want to go ahead and do the check. And in fact, let me give you a big hint. Let's say you get to a problem and you can't even remember how to start it. You can still get your bonus points. How are you going to have to do that? You're going to need to make up an answer. Just pick a couple random numbers and stick them in here and check and see if the answer is right. You're not going to get any credit for the work or the right answer, but if you take that random answer you came up with and you check it, now who knows, maybe it's right. You could get really lucky, right? Chances are it won't be though, but if you show the check and you circle this, no, you're going to get bonus points and you're going to get half of the credit for that problem. Okay, you get what I'm saying? Don't leave anything blank on this quiz, even if you're like completely blank on how to do a problem. Okay. Let's just do one quick problem down at the bottom of the page. I just want to remind you guys how to do equal values. It's been a while since we've done one of these together. Some of you have already worked this problem, and if you're done and you want to go ahead and start working on that homework, they're over on the counter there. Make sure you're grabbing the correct one. You should have already gotten number 6. But I'm going to go through this just to remind you, because this will be on our quiz. We'll have a couple of these types of problems. These are the problems where it's got y equals for both equations. And when we see this, what we're going to do is take the other side of our equations and join them together into a single equation, just with an equal sign in between them. So I'm going to take these two things and put them together into a single equation. So 4x plus 5 and negative 5x minus 13. And that gives me an equation then that I can solve and figure out what x is. So I'll go through my steps to solve here. I have x's on both sides. I think I'm going to choose to get rid of the negative 5x and go plus 5x on both sides. Gives me a 9x here, plus 5. Those are going to cancel, so I just have the minus 13 left over. Now I need to focus on the side of the equation with my x, which is the left side here, and I need to try and get rid of both these pieces, the 9 and the plus 5. So let's do a minus 5 on both sides. Those will cancel, so we've got 9x left over equals, that's going to be even more negative, negative 18. When I'm solving, I always like to save division for the last step in case it causes a fraction. So that 9 is multiplying, so we will divide on both sides by 9. X equals negative 2. All right, we got half of our answer here. I still need to find y. To do that, I'm going to go back to my original two equations, and I'm going to ask myself the question, which one looks easier to deal with, the top one or the bottom one? Top one has smaller numbers and they're all positive. I'm going for the top one. If you want to challenge yourself, go ahead and do the bottom one. I'm going for the top. I'm going to rewrite it, but I'm leaving out the x this time because I think I know what x is. We came up with negative 2 for x. And then we can finish solving this and we will have answer. If you're picking up the homeworks, make sure you should be grabbing homework 5. You already got 6 on Friday last week. We went a little out of order. 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. So I think that my solution is -2, -3. But I'm going to check. And I'm going to check at the speed that I normally would if I were working these myself. So you can go ahead and check yourself, but I want to show you that this really doesn't take that long to do. I'm going to go back to my original equations and write them again. And I'll plug in my solutions. My x was -2. My y was -3. -3 equals -8 plus 5. -8 plus 5 is -3. That checks. It's going to be +10 minus 13. And that's -3 also. That checks. Okay. And it's that quick. That was probably 20 or 30 seconds tops. So once you've practiced checking, it's going to be really quick for you to do. Now, do I expect you to check on every single homework problem? If you have time, I would check a couple. Make sure you're getting quick with checking. But on your tests or your quizzes, yeah, might as well, right? We all make these silly little mistakes from time to time. So we might as well check. Right. So a big thing for today is when we are checking solution to a system of equations, we have to check it in both the equations. All right, we're going to switch gears here.